Hello community. Let's talk about pointers, right? So let's make a simple pointer. So we do the box new to place something on the heap. Let's make it 32 and make the type U64. Alright, so now we got a box value of this. Now we want to point to this. We can make a pointer if we say into raw. And now we got a pointer, right? Now with this pointer, we can, for example, debug it, right? So let's pointer 2 is pointer. We see it's not a problem essentially assigning it or moving it, right? Let's say, yeah, so this all is fine. But now let's try to debug it. Right? So try to debug the pointer. Now, once we do this, we get this unsafe error, right? So this requires unsafe because we're now starting to access memory, right? So unsafe pointer. And now essentially we have some good solid code. So cargo run. So here we see, okay, pointer is 32. Right? So let's play a little bit with this pointer, right? Because this is a mutable pointer, so we can assign something to it, right? So let's remove this. Let's now say we want to have a pointer to be 64. So we double it, right? Now, again, we get this unsafe thing because we're accessing memory and we are actually changing stuff, right? So again, I have to put it into an unsafe block. And what we get now is, if we debug it afterwards, we actually see that we changed the memory inside of it. So let's do something interesting. And let's, for example, make a vec. V, it's a vec. And let's put in the values, not to 5. So now we can have like pointer into a vec. So let's say pointer is, let's imagine we are accessing the first element, right? This is a reference. Now let's convert it to a mutable pointer, right? Mutable of an I32. Now I'm interested if I play my U8, so we have to like make this a U8. Just to make it simple. Yes. So it's mutable, right? We just want to change it. So we have to make this. This also needs to be mutable. So muting in it. Now we got a mutable pointer to some kind of place inside the vec, right? So what if we would now change that pointer? So again, because we're dereferencing maybe in the unsafe domain. So now we can say, okay, pointer equals, let's say, again, the meaning of life, right? So this saves. Now, let's see if we can debug the vector. Let's print, and exactly we changed the first value. Now we got something interesting on pointer. It's called the offset. And this lets you essentially like index into, let's say, the memory area you're pointed to. So now if you want to like change the offset 1 to 32 or 42, that works. Now we can go to 4. So we have the fourth item, and now we can also get the fifth item, right? And what now if you would go and take the sixth item? What would do this? Okay, this still works, but now we are writing somewhere in memory in our program, which is not something we want to do. Let's see what happens if we do this extreme way. So we have like 1 million. It's still not a segmentation fault. Let's make something more. And finally we get a nice segmentation fault. So this is the danger essentially of using these kinds of things, because you're not in an unsafe domain and you can crash your machine, right? Which is the whole idea of it. Okay, now I hope you enjoyed this very short tapas on unsafe cost and pointers. There's something else which is interesting to show. It's like, for example, pointer. You can also make from the standard library. You can make some null pointers. So null mute, for example. This gives us a nice little pointer to unknown because it doesn't need a type, so we just give it a type. Let's do it like this. So now we get a very nice pointer to a mute, and probably we can crash segmentation fault system immediately if we start assigning this some value. Right, and yes, we get a segmentation fault. Why? Because this is now like a null pointer, right? Well, the interesting thing of these null pointers is that this allows us essentially to create structs. So imagine essentially we have a tree struct, and this tree struct has some nodes as a root, which is a mutable pointer node, and then we have a node which has a parent, for example, parent which is also mute node, and we have some data inside this, right? So let's say we have children, which is exactly a vec of mute node, and we have maybe some data. Just evacuate. So now we have everything, right? So this would be very interesting because this would build like a tree in unsafe code, right? And then imagine we make a new function for this tree, and this is why we sometimes need this these pointers is let's for example let's make a new tree, right? It's more interesting. So we have new with the root nodes, right? And let's imagine like we always start from scratch, and now we can do like standard pointer mute. And then the type system will make sure we get here like a nice pointer to mute, right? So one could imagine essentially like building a self-referential struct in Rust using unsafe code using these pointers, which will help enormously essentially in performance and let's say like facets of development, right? Because let's say, but trees is a whole different subject, right? Which we'll cover first, but this shows you essentially this pointer new. You can also have like something called a constant pointer, which is just normally the null pointer, which should read only to a read-only memory. And just for this, like a constant pointer is also protected again by the compiler that we don't assign anything to it. So if we, for example, would do the constant pointer, we will assign 64, then it would say like, oh, cannot assign, right, which is behind the const pointer. Yeah, so the data to first cannot be written to, right? What we can do, of course, is say, okay, we take this pointer and we convert it to a mutable pointer, u32, and then assign it, which works, but this will immediately lead to some undefined behavior because it's again pointed to 0, right? But if this, let's imagine that this pointer would be actually a pointer living on, say, let's make a value which is 32 u32, right? And let's make a pointer, let's call it ctr is, and this will then be a constant pointer, right? So we reference this value as constant pointer of type u32, and then we convert it to this one, and then it should definitely work if we actually debug it, right? Imagine, remember, because we're debugging, we need to dereference the pointer in an unsafe block, otherwise we cannot access the memory. And yes, what we see, 64 and 128, just to make sure. And all this works like a charm. So in a recap, like creating pointers, safe, dereferencing pointers, say moving pointers, in the sense of assigning them, moving around, let's say, creating them is also safe. Creating pointers also with the unbox, let's say the from raw, everything is safe. But then when it becomes unsafe is when you deref the pointers, and of course when you deref and assign new values pointers, then all that work has to be unsafe, and you have to reason about it, right? And then the last point to remember is that standard pointer, null, and the commute variants are there essentially to instantiate essentially new pointers if you're building structs and you don't have any value state, right? Yeah, another thing also to remember is if you make a pointer like this and you do like this, no, good. Then the nice thing is like we have this method on P. Again, a type, it's a type, it's going to be like 64. Then we have a method on the P which says is null, right? To check essentially if the value already has been assigned or not, right? And it's also a way essentially to see, for example, do we already have something here, right? Or of course you can wrap it into an option, which is not a problem as well. Okay, I hope you enjoyed this very quick and concise walk through pointers and unsafe pointers in Rust. Please like and subscribe, and if you have any questions or you want to see like a specific tapas, let me know and I will make it. Thank you very much for watching.